Hi everyone. In this video, we are going to look at some exponential and logarithmic functions and look at different features of them, comparisons, and so on and so forth. So what I want you to notice at the top of this page is that we have four graphs. We have f of x equals 2 to the x, and its partner graph h of x equals log base 2 of x. We also have g of x equals 5 to the x, and its partner m of x equals log base 5 of x. So something that I mentioned in my last video about log functions and exponential functions is that the base of the log, so base 5, is the same as the base of the exponential, and these are inverse graphs or inverse functions. So the base of 2 is the base of the log in its inverse function. So we have these two logarithmic graphs are what we're going to focus on the most. And we do have some highlighted points on here. A little bit hard to see, but I will make them a little bit more visible with a pen. So we've got these points highlighted here. All right, so I'm going to look at where do the two logarithmic graphs intersect. And that point is 1, 0. So if you're thinking of a logarithmic function or an exponential function, so the x value is 1 and the y value is 0. So log base 2 of 1 is always going to be equal to 0. Log base 5 of 1 is always going to be equal to 0. The reason why this is the intersection point, think about back in our log unit, if we were to transform this into exponential, 2 to the 0 equals 1. 5 to the 0 equals 1. Anything to the 0 power is going to be equal to 1. So if you take log base anything of 1, you're going to get 0. So any logarithmic function should have this point. This is like the golden point of the logarithmic function. So now it says, for which values of x is log base 2 of x less than log base 5 of x. So we're looking at where is the yellow function below the orange function. So here we can see it's above, so log base 2 of x is greater than. Over here, it crosses at that point, and for the values x is less than 1 is where you have log base 2 of x less than log base 5 of x. Over here, which values of x is log base 2 of x greater than log base 5 of x, and that's over here. So where x is greater than 1. Does either graph ever intersect the y-axis? If you're intersecting the y-axis, that would mean that x equals 0. And since log of 0 does not exist, that means that it does not intersect the y-axis and it cannot intersect the y-axis. So this is called an asymptote. Any basic log function, and I say basic because we're going to end up transforming this graph in the near future. So any basic log function will never cross the y-axis. And the y-axis is actually called an asymptote in this situation. Now, what an asymptote is a line that a graph approaches but will never hit. So x equals 0 is going to be an asymptote in this situation. It's a line that the graph approaches but never actually hits. All right, so the tables below are going to be really, really important and helpful in actually completing a logarithmic graph in the future. So the points that we have, if we have 2 to the x, 2 to the negative 1 is 1 over 2. 2 to the 0 is 1, and 2 to the 1 is 2. Now remember, 2 to the x is an inverse of log base 2 of x. So if I take those values and I swap them, the x's become the y's, and the y's become the x's. And if you look back up to the top of your graph, you can see those points on the log base 2 of x and on the 2 to the x. So now my next one, 5 to the x. Negative 1. So 5 to the negative 1 is 1 over 5. 5 to the 0 is 1. And 5 to the 1 is 5. If I take that and flip-flop it, I have 1/5, comma, negative 1, 1, comma, 0, and 5, comma, 1. So what I'm about to show you is how we are going to approach logarithmic functions in the future. Whenever you need to graph a basic log function, we're going to use this trick. So if I have, so this is exponential. Any basic exponential is a base to the x. Any basic logarithmic is log base b of x. Now that b can be any number as long as these are the same if these are inverse functions. So for exponential, we always start with those 3 key points. So negative 1, 0, 1. Now if you notice in these two exponential functions, whenever you have x equals negative 1, the y value is 1 over the base. So I'm going to call that 1 over b. If you have the value 0 for x, the y value is always 1. And if you have the x value of 1, your y value is the base. So this basic table here, negative 1, comma 1 over b, 0, comma 1, and 1, comma b, this is your basic exponential table with those 3 key points. If I flip this, the x values are 1 over the base, 1, and the base. The y values are negative 1, 0, and 1. This is one of the most important key takeaways you can take from this video, creating a log function. I'm actually going to go into a random paper, pick a random base, and make tables using it. So if I have, let's call it y equals 7 to the x. The inverse of that is going to be log base 7 of x. So the table for the exponential function, -1, 0, 1. 1 over 7, 1, 7. The table for the log function, the x values are 1 over the base, so 7, 1, and then the base. The y values are -1, 0, 1. So given any base, you can always do this. So this is 1 over the base, 1 base. And then the outsides are -1, 0, 1. This is super, super important as you go forward.